Lesson 3-4, Solving Exponential and Logarithmic Equations. To solve exponential equations, and those are the ones where x is the exponent, there's two methods. We have the shortcut method, which is the one-to-one method. We rewrite both sides with the same base. But this only works sometimes. Like most shortcuts, it only works sometimes. And it only works if you can rewrite both sides with the same base. We've already solved ones using this. All right, so the left side, the base is 1/5. Could rewrite 125 with a base of 1/5. Well, it's reciprocaled, so we have a negative exponent. And 5 to the third power is 125. So 5 to the 3 is 125, and because it's reciprocaled, it's negative. And then we say, oh, the bases are the same, therefore the exponents are the same. The general method for solving exponential equations is to do the opposite, and the opposite of exponential is logarithm. So we'll take the logarithm of both sides. So the first thing we need to do is isolate the exponential part. So we'll get rid of the 5. And then get rid of the negative 3. And then we need to take our logarithm of both sides. And so what would be a good base? Well, the base here is e, so I would do logarithm base e, or natural log. That'll cancel out, leaving x equals the natural log of 1, which any logarithm of 1 is 0. So x is 0. And of course, you'd plug that back in and check to make sure it works. Let's try another. Again, we need to isolate the exponential part, so let's start by subtracting 4. And then we could divide by the 6. And now we have the exponential part by itself. So now we need to do the opposite of exponential, which is logarithm. So I'm going to do logarithm, and I'm going to do base 2 since we already have base 2. So there that cancels. So we have t plus 5 equals log base 2 of 7 over 6. Finish by subtracting 5. And then you can put that in your calculator. And your calculator should tell you it is negative 4.778. Of course, plug that in to make sure that it works. All right, let's try solving this one. This one looks more complicated. Oh, but maybe if we rewrote it so as e to the x squared minus 7e to the x plus 12, we would notice that it's in like a quadratic, where we have it squared into the first. So since it's 3 terms, we might be able to solve by factoring. What times what is e to the x squared? It'd be e to the x times e to the x. And what times what gives us 12 is maybe negative 4 and negative 3. That does add to negative 7, so this works. So then I take each of those, since I factored, equal to 0. First one, add 4 to get it on the other side. And now I need to get rid of the e. So it's e to the x. So the opposite of the exponential is logarithm. And I'll do log base e to cancel out the base e. So I have natural log of 4. The other equation, add 3. Then take the natural log. I'm doing natural log, so it cancels out the base e. And x is natural log 3. If we put those in the calculator, it's about 1.386 and 1.099. And of course, you should check those to make sure they work, and they do. To solve logarithmic equations, again, there's two methods. There's the one-to-one property, which is a shortcut, but only works if you have log equals log, and they're the same base. Wait. Oh, but this one, we could just add the natural log of 3 to the other side. Notice that it's the same logarithm, so the stuff in the logarithm, the x and the 3, have to be the same. The general method, which works all the time, is to do the opposite of a logarithm. So for solving a logarithm, we need to use exponentials. So we're going to exponentiate both sides. So in other words, we're going to turn both sides of our equation into exponential functions. So let's get the logarithm by itself first. Let's subtract the 6. And then divide by a 3. And then we need to, let's see, what could we do? What's the opposite of natural log? Well, the base of natural log is e, so I'm going to make e the base of both sides. So now what was there is now the exponents. If I have a base and log with the same base, they cancel out. So it becomes e to the negative 2/3, which is approximately 0.513. Put that in your calculator. Double check that it works. Let's try the next one. Well, this has two logarithms. Oh, but conveniently, we know how to condense logarithms. So when we're adding logarithms, we can redo it as multiplication. So we'll multiply the x and the x minus 9. And now we have just a single logarithm. So to get rid of that logarithm, we're going to do the opposite and do exponential. The base of this logarithm is 4, so we'll use the same base. What was there is now the exponent. The base 4 and the log base 4 cancel out, and we just have x times x minus 9 equals 4 to the first. Well, 4 to the first is just 4. And now we can probably solve this. Let's distribute. And let's subtract the 4 to make it equal to 0, since it is quadratic. We could try factoring. I'm going to tell you now, factoring doesn't work. So since factoring doesn't work, we'll have to use the quadratic formula. So negative and negative 9. Negative 9 squared. A is 1. C is negative 4. A is 1. It's be 97 in the square root. And 2 on the bottom there. Can't simplify the square root of 97, so we'll put this in the calculator and we'll get two answers. Get 9.424, and we'll get negative 0.424. Well, we need to check our answers. So we check the first one, we plug it in, run it through the calculator. It works. We plug in the second one, and it gives us Error. Why? Because the domain of logarithms is 0 through infinity. So I can't do this negative. That's an extraneous solution. We only have one solution, and it is the 9.424. The negative one does not work. You cannot plug it in. The other way to solve any equation is graphically. But it's usually a last resort, and only try to do it when other methods don't work. So you make your equation equal to 0. You graph it, and you find your x-intercepts, or the zeros. Your graphing calculator should be able to do that for you. So let's solve this. Now this, we could use a change of base formula and solve it that way. Or we'll use it to demonstrate the graphical method. So I'll make it equal to 0. I'll subtract the natural log of 2x from both sides, so it equals 0. So I'll grab my calculator, go to Grapher. I'm going to use my log base function here. So the base is 2 of x, and we're subtracting the natural log of 2x. And then I'll look at the graph. All right, you can see that it looks like the x-intercept is somewhere here between the 4 and the 5. I'm going to go up and I'm going to calculate a 0. And you can see it tells me it's x equals 4.786.